So I'm here to talk with you about some of the gotchas that you can run into when you're using Power BI. I know that I've worked with clients or been working myself and found that we've lost time just kind of messing with a couple of things that if I had thought about them beforehand or had an opportunity to see those issues before, I might have saved a little bit of effort trying to solve a problem or work around an issue. So I thought I'd just pull those together and list them in a gotchas session for you. Just a little information about me. I am a principal consultant here at PragmaticWorks. I have a blog, rachelmartino.com, which will host an article about these gotchas, and I'll post the slides, which really don't have much content. There's only one reference slide there. Maybe I'll just put that in the article. And some other information as summary commentary about this as well in that article. Here's a picture of my husband and myself this summer, and I am a SQL Server and Oracle developer, and I've managed IT groups, application development, BI, and analytics as well for quite some time. My orientation here at PragmaticWorks is helping our clients move towards building a data culture and helping them resolve issues related to their BI environments or their databases. I'm actually in the Boston area. If you know PragmaticWorks, you know we're headquartered in Jacksonville, but I'm up here in Boston. And I would love to get my hands on the Ravelry data set. If anybody has access to that, I'd be thrilled to hear about it. But we're here to talk about Power BI today. Power BI is great for reporting, building dashboards, collaboration around dashboards and reports, and for very helpful for data discovery at a basic sort of clawing around in your data level, getting familiar with it. We're going to experience the reporting and the data discovery levels today. I'm not going to get into using the Power BI service today because I'm really talking about the gotchas that can affect you while you're building your Power BI solutions. But what is Power BI? I suspect most of you are familiar with this, especially since this slide is liberally borrowed from the deck that Sean used in his great presentation last week. So just as a summary, it's a suite of business analytics tools that allow us to analyze data and share insights. There is the ability to put together a dashboard, which is what you see on the right, pulling information from multiple reports and multiple report sources into a single location and allow people to drill back to their reports and drill down within their reports. And we're going to look at that activity today. But most of today is going to be a demonstration of these activities. That was almost the end of the slides. I think I have two more. But you should now be seeing an empty Power BI solution. And today I am going to work with you to build a couple of reports, and I'm going to start from my data is in my database and move forward from there. Given that, I'm going to hit Get Data, and my database is actually a SQL data warehouse. So the first thing I'm going to have to do is put in the information about what server resides on, and the database name. And today we're going to use direct query. I find a lot of clients have questions about what you can and cannot do with direct query and how powerful it is. So given that we're working with this rather large data set, I thought this was a good opportunity to put the data in a data warehouse and access it through direct query. This means that I am not importing the data into Power BI, which is a big difference going forward between whether your data becomes hosted in the Azure Power BI service once you publish, or if your data stays resident in your data store and is merely accessed by the Power BI service. So when I click Direct Query and hit OK, what's happening is Power BI is reading the data source, and from now on, for every activity that takes place, the data access will go back to the database and pull back results only. This is great for companies that just can't quite push their data out to Azure for security reasons or for auditing reasons, and they need to keep it stored locally. However, they're interested in using Power BI reporting. So I'm going to grab, there's a whole bunch of information in my database, but I'm going to grab two tables, the date table and the New York City taxi trips table. Just as this loads, the New York City taxi trips data that we're going to start from actually has in it 173 plus million rows. So I just connected using Direct Query back to that information, and there's 173 million rows worth of data there. Now, for the purposes of this demonstration, I am going to edit the query and limit some of the rows, only because it does take a little time to update. But if we have a little time at the end, I will show you some queries that are running against the full data set, and you can see the difference in time. But I do want to get to the gotchas and the tips. I know some people are curious about large data sets. Once I have connected to my data set and I click Edit Queries, which is what I just did to start the query editor, the query editor starts in a separate window. So I hit Edit Queries here, and it opened the query editor in a separate window, which I've maximized so that you can see it. And it has a set of tools that I can use to transform my data. Now, one tip that I like to mention if people have a lot of environments is that you can use the formula query editor to share scripts from one data source to another. So if I come here, actually I'm not even going to grab the whole script, I'm only going to grab part of it, and I will explain what this is in a moment. And I come into the query editor. Normally we would do some activities, maybe split a column or define a data type here. But another thing you can do is just go right into the query editor script, and you can edit these lines manually if you're interested. So the top part of the script lets various data sets be set equal to some functions operated on previous data sets. So I am going to edit this by adding some lines here. And when I do that, and I put a comma between each of the statements, I've added a new data set called filter rows that takes this New York taxi trips data and it filters out any row that contains, so I've got not contains the word passenger in the passenger count field or space passenger in the passenger count field. So it's not important exactly what the syntax is or what I'm doing. The point is that this line is a filter line, this line is a filter line, and they're put together by commas, and in each case they operate on the data set that was created in the previous scripting line. So because this is a scripting language, I can edit the script manually. I've added these statements, and when I hit done, those statements will be applied to my current table. So I've saved myself a lot of effort filtering this data set. And if you're interested in seeing what happened, you can go back to a command and click on the little gear next to it to see what activity it's doing. And in this case, what I did was I set up a filter for the pickup longitude field, and I am filtering where it does not equal 0. I've established through some previous data discovery that I've got a bunch of longitudes that are 0, 0. Well, longitudes and latitudes together, that pairs that are 0, 0. And I'm just filtering those right out. They're not giving me data that I need. And I've done the same thing for the drop-off longitude. And I've also filtered, excuse me, missed the gear. There we go. I also filtered the medallion field. I mentioned I was going to take a subset. I've taken the first 50 medallions out of the database so that I'm only working with a subset of the data. So once I do that and apply this to my data set, I click Close and Apply, and now that data is pulled into my Power BI desktop environment, and I'm ready to start working with it. So I want to do a little more data discovery. The first thing I'm going to do is I'm going to lay down a multi-row card, excuse me. And in that multi-row card, I'm going to drop in some of my facts. And I just want to get an idea of what they look like. So I'm going to drop in trip distance. And if you notice, trip distance is defaulting to a summarization, but what I'm going to grab is the max. I'm going to do the same with trip time. Oh, that didn't work. Let's give that a click. There we go. And we'll maximize that as well. Sometimes it takes a moment to update, and if you try to operate on a field as it's taking a moment to update, it won't pick it up. And we'll grab passenger count. And it's in there, so now I can go ahead and make a modification on it. So now if I take this visualization, I can change the size of these labels so you guys can read them. In the data labels, I'll make those bigger as well. So now we can see that my max trip distance is 102, and I happen to know that that's miles, but there's nothing here that tells me that. My max trip time in seconds is over 4 million, and my max passenger count is 6. I'm actually pretty happy with the trip distance. I think that's probably a reasonable maximum over a year for New York City taxi data. And the maximum passenger count is 6 passengers per trip in a trip, and that's pretty reasonable. That would be about as many as you think you could fit in a New York City cab. But I don't think the maximum trip time was really 4 million seconds. It's about 26,000 seconds in a day, so we've got some kind of data issue here. And I can save myself a lot of time checking the minimums by just copying and pasting my visualization. So I just went to my original visualization, I did a Control-C to copy. I went to my new location and I did a Control-V, and I pasted it, and now I'm just going through and I'm just changing all my maxes to mins, and I can see my minimums. So my minimum trip distance is 0, my minimum trip time is 0, and my minimum passenger count is 0. I'm not happy with those either. So I see that there's some more data cleansing that needs to be done here. Let's go back to edit again, and let's clean this up a little bit more. Now, I don't have to, let's get to the New York taxi trips table. I don't have to get into the advanced editor and use the script. I can use the manually applied steps and very quickly modify my trip time in seconds column, and I can apply number filters. But let's think about this. I know that 4,300,000 rows is, seconds is way too long, but I'm not really sure what is a reasonable time. There's no reason I can't go back to my data source and run some queries there. So I'm augmenting my discovery that I'm doing in Power BI with discovery in the database. Sometimes we forget that we can just go back to the database and run a query. I've got this prepped with, I've pulled out the pickup and drop off longitudes of 0, 0, and I can run this query and see my data. Sorry, it must have cleared the cache. The data for all of the trips that are greater than, that are not 0, 0, actually that's going to pull back like 170 million rows, I'm sorry. Let's just pull back, I should have left this the way it was, my apologies. Let's just pull back one full day, there we go. Interestingly, this data set provides us with information about the medallion, the hack license, some other columns that we're not going to use today, pickup date and time, and I've combined date and time into a date hour as well that we could use if we were doing some time of day analysis. The same with drop-offs. But here's our trip time in seconds, along with trip distance and passenger count. And we can see now that I've ordered this by time in seconds, these are some really big numbers, and there's more than one row of them. And in fact, if you watch the drop-off date column, interestingly, they're all in August. So it appears there was some bad data gathered in August. And if we scroll down, we're going to see a big break. So for everything that was over a day, I'm sorry, I went a little too far, there's this big jump from 86,000 seconds to 4 million. And all of those 4 millions, if you look over to the left where we see the drop-off date column, all of those took place in August. In fact, so did the 86,000s, by the way. I could spend a little more time evaluating what a reasonable trip is, but I'm going to set that at 26,400. I like that number. It's a full day, and I think it makes sense. So I'm going to say that I'm only going to use rows that are less than or equal to 26,400 seconds. So I hit OK, and now I've added a new filter. When I close and apply, now my little report that I created that is helping me do discovery and validation of my data now shows that the max trip time is 9,000, almost 10,000 seconds, which is a lot more reasonable. If 26,000 is a day, then probably the fact that it's dropped back to less than half a day is pretty reasonable. So I'm just going to name this report discovery. Actually, I'm going to name it validation. So this is just a very, and I'll show you down in the corner, I've just named that validation on the tab, much like you would do in Excel to name a sheet. So we've now validated our data to a certain extent. Because this is a demo, I'm not going to deal with all those zeros and minimum trip time, minimum passenger count. Just be aware that this is the page that I could use repeatedly coming back here if new data were being added to this New York City taxi data, and see whether I have some other rows that are somehow escaping my filters, and I'm getting some crazy data on my facts. But let's think about our facts for a minute. The fact information is stored in this table, New York City taxi trips, and right now a lot of these fields have a little summary sigma next to them, and that indicates that their default summarization is to sum them, and I'm going to change those. It's one of the things I like to do right when I pull up a new set of facts, is to make this modification so that I'm not accidentally adding up longitudes or accidentally averaging something, because that was, for one reason or another, the way the default came up. We're counting. So let me do the same with our latitudes, which, I'm sorry, for our pickups. Rate code also should not be summarized. Now, another thing that is important is to name your fields so that they represent the units of measure. We talked already about trip distance. The fact is that here I can see 102 for max of trip distance, but I don't know what the unit of measure is on that from that field name. So I'm going to do two things. I'm going to create a measure that is trip distance, and I'm going to put in the unit, and it's going to be a sum of trip distance. Now I do this because even though my default summarization on that field is still set to sum, and I'll explain why I left it that way in a little bit, it is still good to have a measure that you know is giving you the total of the values that are being summarized for that field. And it's useful for self-service reporting, in fact, to the extent that frequently we will completely hide the original field so that people use the field that is summarizing, so that we don't have any confusion about what totaling action, what summarization action is taking place on that field. But I'm going to leave trip distance there for a minute because there is another reason we want to keep it around. So I'm going to create another one that is trip time, and it's in seconds. We saw that our trip time field was actually called trip time in seconds. And I want to make it clear that that number is seconds. So now we've got a new measure for that. But it's important to do that because I might think that it makes more sense to report on trip time in minutes. To do that, I'm going to create a new measure, and that's what I'm actually going to use in my reports. So I'm going to use the trip time in seconds measure, and I'm going to divide it by 60 using the divide function. Now I use the divide function because it is a DAX function that will provide an alternate result if the denominator of the ratio is 0. In this case, that's not going to happen because 60 is a static number, but we just want to call that out, so I went ahead and added that for you. And one thing that I don't have here is a way of counting trips. Normally, we might add a count of a unique identifier field in order to provide a total count of trips that we can use in our calculations. But in this case, I don't have a unique identifier. I have the medallion, but every medallion is used many, many times. I have the Hackney license, but again, each of those Hackney license holders is operating many, many trips. So I'm going to use just a little trick. I'm going to create a new column, and because all I care about is counting these anyway, I'm just going to call it a trip, and I'm going to make it equal to 1. So now I have this field called trip that is equal to 1 for every row, and I can create a measure which is trips, plural, I don't need units because a trip is a specific unit of measure, but I will sum my trip field here. Trip count might also be a reasonable identifier for that one. That might be less confusing with trips, with the trip field. But it's important that we are able to count these as we move forward and represent how many trips were taken in over periods of time. So let's see that. So we're going to create a graph, and I'm actually going to use the clustered column and line graph. So I just click on it to put the visualization on the page, and let's drag over the pickup date as our axis, and let's get the column value to be the number of trips, and let's get our trip distance in miles as a line value. So we've pretty quickly placed those values on the graph, and we can see that we have some bars and some lines, but it's actually very jumbled. Everything's on here, every date, because of the pickup date. And what I'd like to be able to do is limit myself to seeing 1 month or 2 months, or maybe all 12 months, but the sums during the month. But I can't do that because at this point I don't have a date field here. So the next thing I want to do is I just want to lay in, because this is going to be helpful to us in a minute, I want to lay in another multi-card and put in the values for trip distance. Oh, sorry, that should have gone here. Trip distance, and I can drag it into there if I'd like, and trip time, and the number of trips. So as I do that, I can see that some of them have commas and fractional parts in the form of decimal places, and some don't. So I want to standardize my representation of these. I'm going to set my formats on these right away. Not 20, but that. And so I'll do that for trip distance. I'll do that for trip time. And I'll do that for trips, which is a whole number, so I don't need to make that modification. So now, if I just come here and make this a little bit bigger, you can see the formatting. This we did not mean to place. And I'm going to use this in a minute, but the graph itself is very, very busy, and I have no way of summarizing because I do not have a month column in my New York taxi trips fact table. But I do have the dimension table date that I've added. However, even if I was to add a slicer on date, let's grab, let's say, month name and put it in our slicer, it won't have any effect because we haven't set our relationship yet. And I want to go to the relationship view and show you that from here we can add the relationship between the calendar date and the, in this case I want to use the pickup date. Oh, here it is. And I'll do that by dragging and dropping. Now there's a very specific reason why I chose the calendar date column and didn't create a smaller, more memory efficient surrogate key that was an integer and substitute that for the key, the foreign key relationship between these tables. The reason I didn't do that is because we need for Power BI to recognize date as a date if we're going to use any time intelligence. So I use, in my date table, I use a calendar date field that is of a date type. And I join it to a date field on my fact table that is a date type. If you're going to use time intelligence, you need to do that. Unlike Excel, we can't identify the date table as a table of type date. This Power BI doesn't work that way. But if we identify, if the foreign key relationship, the relationship between the date table and the taxi trips table is on a date field, then that time intelligence will be enabled. And there's something else I want to show you here too. When I dragged from calendar date to pickup date, it correctly identified the field in each table. So in the top I'm seeing that the calendar date is selected in the date table. In the middle I'm seeing the taxi trips. I've selected the pickup date column, so that's great. There's a one-to-many cardinality, which makes perfect sense. I've got one date per day and many, many trips per day. I can cross-filter in a single direction, but I can also cross-filter in both directions now. I can do that because cross-filtering for direct query, remember we're using direct query, was put into preview with the last version of Power BI. Honestly, I'm actually one version behind. I apologize for that. But the cross-filter direction here, I'm going to set to both, and we're going to see how that affects us here in just a moment. So I'll hit OK, and the relationship is created, and it has two arrows here on the relationship to identify that it's bidirectional. Now, when I look at my values, I had already selected November in my date generated slicer, and because of that we're only seeing November here. Immediately we see the results of that relationship affecting the behavior of the visualization. We're seeing only trips for pickup dates, that's what's on the bottom, in November. And in fact, if I click on a date in here, and we filter this, sorry. All right, I'm going to have to do that a different way. But anyway, what we can see is that the ability to filter by month is now enabled. And if I modify my interactions, actually, no, they're modified. I'm sorry, I'm trying to show you something that's not working, so I'm going to give that up. So this is how you set up the relationship between the two environments, between the two tables. One thing you'll notice about month name is that they're all out of order in here, and so we do want to set up our sort by column on those. And the date table that I have used has in it a month number column. I've created a date table that I use. It's actually in the database, but I'll show it to you here in Excel, which is where I originally created it. And the date table has in it some fields that are very useful for sorting months and days of the week. So we'll sort day of the week by day of week number, and quarter by the quarter number. And that enables us to have a nice and neat graphical representation, but also it's important to be able to see the patterns as they move across the time period. And you won't see those if things are out of order. So if I was to change this table to, instead of use the share axis of pickup date, I put in my month abbreviation. It'll refresh the data, but they're still in the wrong order. So at this point, I realize that month abbreviation, if your values are in the wrong order, change your sort by column. If you don't have a sort by column, create one, but it's important to note that there is one month number per month abbreviation. Each month, January, has one single month number. 1 is the month number for January, 2 is the month number for February. If I was to say, no, it should be sorted by date, I will get an error because there are many dates in the month abbreviation of JAN. So month abbreviation can't be filtered by date because there's more than one date. So very quickly we'll make that change to go to month number, and our our months will straighten out on our graph. And we want to do the same thing with day of week. We need day of week to represent the day number accurately. So, oh, sorry, there isn't a specific day number. My mistake. Day number is actually a number within the month. What I wanted was day of week number. There we go. So it was happy once I did that. Another formatting activity that's very quick and easy and makes a big difference is building hierarchies. Now, sometimes what we'll do is we'll create a hierarchy by dragging multiple fields into the axis location over here where, sorry, let me get rid of that little, here we go. And here I've got year name and month abbreviation in the shared axis designation, and because of that now I have the ability to drill down from year to month in my graph. But there's a shortcut for this, which is that if you start to drag fields over each other in your fields list over to the far right, I'm just dragged quarter name on top of year name, month name on top of that, and day name, a day of week on top of that. Now I've built a hierarchy which I can rename, and I can just call it my time hierarchy. And instead of piling on the shared axis pile with year name, quarter name, month name, etc. each time I want to reuse it, I can just drag my time hierarchy over. Now, if you haven't already gone through and specified the sort order on each of your values, when you start to use that hierarchy, everything's going to be out of order. So make sure that you set those on your data fields before you start to put those together. So now I've got a nice hierarchy that starts up, we're actually drilled quite far down, let's get all the way to the top. Starts with the year 2013 and shows me the number of trips and my trip distance for the whole year. And as long as this button is black, I can click on a time period and drill through that time hierarchy. Now, I want to spend just a minute explaining these two buttons here because this can cause some confusion. If I click on this button and it's selected, and I click on a column, then I will drill down into that column. If I click on this button, I will drill down to the next level in the hierarchy across all of the quarters. I'm going to go back now. But if I had drilled down, for the using the forked drill down, I would see the previous quarter name along with all of the months. Now, this isn't as visually representative at the month level because we only have one instance of January in my data set. But if I were to do that again, now what I see, I've gone down the fork showing the days of the week, and I'm going to zoom in on that bottom corner so that you can see that the first column is the quarter 1 sum days in January. All of the sum days in January. The next column is the quarter 1 Mondays in January. So I've gone down to the leaf level in my hierarchy, the lowest level in my hierarchy, and I'm seeing the days of the week, but I'm seeing them totaled by the previous hierarchical levels, by the quarter and by the month. And this will be markedly different than what happens if I were to drill down in this way. I drill down across all the quarters and get one value for every month, not as vivid because I only have 1 year, but if I do it again, now I'm going to get one column for every day of the week, no matter what, and it's summing all the Sundays no matter what month or date they're in. Now, on the other button, if I unclick that, it will not drill down any further. It will select. So when I select Friday, I'm now getting the total of all the trips, 105,000 trips that took place on Fridays. And I can do the same for each day of the week, and it will update everything that is selected here. I want to just change the selection controls here and say that we can select all here. And so it's giving me the total of all the trips for all of the Tuesdays. But it's important that I differentiate between when this button is highlighted with a lowlighted with a black and when it's empty, because if it's empty now and I click on October, now I'm getting all of the trips in October. If I make it black and I click on it, I'm drilling down and seeing everything that happened in October without filtering this value here and the right. So the drill down activity and what they call the highlighting activity, which is what this is, have different behaviors. These symbols that I'm showing you above the other visualizations on the screen are a great shortcut for understanding the interactions while you're in development. If you turn them on, you can see what's going to happen to these different visualizations when this active visualization is clicked. And I can change them. I can say, don't filter this. So now this will always give me all the data, no matter what I have selected over here. And if you turn off edit interactions, you can't see that. Which brings me to another tip. I apologize for the cough. The tip is that you want to be aware of the filtering that is taking place. Make sure you know what interactions are taking place between your visualizations, and also be aware that filters can be set not just at the visual level, but also at the page level. It is possible that we might, for one reason or another, have a page level filter here that says, only give me April data. Well, I might come to this page and forget about that filter. It's scrolled down, it's not visible, and I may be pretty lost as to what happened here and where all my data went. So if you have calculations or visualizations that are not behaving as expected, do yourself a favor and just quickly check your filters at the page level and the report level and at the visualization level to see if perhaps those are causing some kind of issue. I want to create another visualization for you. I realize we have about 10 minutes left, but I do want to spend a minute talking about time intelligence. Time intelligence in direct query is possible. I showed you that I had turned on queries, more complicated queries, and so I want to bring in very quickly our time hierarchy and also our trips. And I'm just going to take year out. We'll start at the quarter level, so this is a little bit more interesting graph. Okay. Now, one thing I didn't mention before is that I can right-click on a point and also access those same activities that I was accessing with the buttons at the top of the visualization. But another thing I can do is see data. And see data is great because it shows you what the values are for every point on your graph. Fantastic. But what if I wanted to see the records? Well, there is a way to do that, but you can't do it with this field because you can do it. Sorry, I'm messing myself up here. So we can see data. All right, I'm going to leave that because that's not behaving the way I believe that it should be. The other thing that I want to show you is time intelligence. So let's create a new measure that will show us the previous quarter. So I'm not going to make you watch me type it. I actually have it right here. And we'll just paste that right in. And I'm using the previous quarter DAX calculation, DAX function. Not all DAX functions will work with direct query, but some time intelligence does work. So previous quarter trips will show me the previous quarter. And you can see that I have Q1, there was no previous quarter, so there's no black line. Q2, the previous quarter was Q1, and it was just a little higher. Q3, Q2 was much higher than Q3, and Q4, the alternative. And we don't see Q4 as the previous quarter for the next quarter of the next year because we don't have any data. But what happens when I drill down into Q3, for instance? The previous quarter is being shown, but it's being shown as a single value across all of my months because for all July, August, and September, the previous quarter is a single, summary is a single number. That's not the desired effect. So I can use a measure, I can use some if statements in my measures. And this is a little bit more advanced, but all of this will be in the blog article. And when I paste this guy in here, what we're going to see is that, let me just paste it in, is that if it's filtered by month, then our calculation is going to be to use the parallel period function to sum taxi trips, and I'm going to use a parallel period of -1 month. Same, but if it's not a month name, then but it is filtered by quarter, then I'm going to use the parallel period of a quarter. And if it's not filtered at all, then I'll use a parallel period of a year, which is missing in this case. So that function has been created. So let's, instead of previous quarter trips, let's put previous period trips in there and see what we get for our months. There we go. Now it's behaving. So we can see that in July, the current trips are 55,000 and the previous trips are about 56,000. In August, we get back to our previous 55,121, which was the July value, but we see that August has 55,417, which is repeated as the previous trips in September, but not in but September actually goes up. So if we were to go back all the way up to our quarter level, we see the quarter graph as we expected it. So I am able to drill down and still keep my previous values visible on the chart by using a function that checks to see what the filter is for the measure and then filters it accordingly. So we've run out of time. We have about 3 minutes left according to my clock. I'll just pop back over to my PowerPoint slides because I did threaten you that I had a couple more, and I think this is the most functional of the next ones. Do we have a moment for a few questions, Liz?
Yeah, absolutely. Let me get through them. Okay. Here's the first one. Does using direct query cause delays in updating visuals?
Yes, it does, because the query for the measures in the columns that you're requesting for the visual, the Power BI calculations are converted into, in this case, SQL statements and sent back to your database, and the summary aggregated answer is returned back to Power BI. So there is the delay of needing to go back to the data source to get the data. I mean, that's just a delay because of the physics of going across the internet in most cases. And then there's also the need for running a SQL query on the other side. One thing I didn't mention, but I do want to make sure that I emphasize, is if you're using direct query and you're running some complicated functions, or even if you're doing simple work, frankly, simple visualizations, no matter what, you want to follow good query performance tuning best practices in your source database. Go in there, set up indexes according to how Power BI is requesting this data. And you may find yourself rewriting some measures to take advantage of different functions that work better, or to do things in a different way that is simpler. And there's information out there on doing this as well.
Okay, I think we have time for one more question. We have many databases on the same SQL server and need information from all the databases. How do you connect all those databases to read all the information?
Yeah, so with direct query, you can use one data source, which is one database on one server. So if you were going to use all of that information, then you would need to put it together into one source and in some way connect to that single source. So it doesn't necessarily have to reside there, but if you were to do, some database connections or something, then just be aware of the performance implication of that.
Great. Well, I know we have several questions that we didn't get to answer to, so I'll be happy to send those over to Rachel, and Rachel always does a follow-up blog for us, so stay tuned for that. As always, the session is recorded, so you will receive an email tomorrow with the link. Rachel also said that she will provide her materials that she used today. Her blog is rachelmartino.com, correct?
That's right.
rachelmartino.com. Yes.
Rachel with an extra A.
With an extra A, that's right. If you guys think of anything that you need that you didn't get answered in this, please feel free to email me, Liz, or Rachel. I'll be happy to pass along anything. Thanks, guys, for joining us today. Thank you, Rachel, for presenting, and we'll see you next time.
Thank you very much. Thank you, everybody.
Bye.
Bye-bye.